please mind my words when I'm saying that in organic chemistry, every time you have to circle back and close the loop. Don't just keep going through it unless until you put your own effort to bring down everything under your purview in your memory. And for that, every time you'll have to jump back and think of, okay, in this chapter I've studied this, and then go into the details. Okay, in this, what all we studied, in oxidation, what all I studied, in addition reactions, what all I study, what all I have gone through. This is how you keep yourself in touch with the subject matter. Otherwise, it is highly sublimable, I would say. Most sublime section of chemistry is organic chemistry. So many things come to you, but all of them will get vaporized. Highly sublimable things. Yes. And that's why my request is be very systematic in your approach. Substitution reaction. Okay, when it comes to substitution reaction, one interesting thing is somebody has to substitute somebody. Yes or no? In addition reaction, a reagent got added. So you had maybe 2 reactants in the beginning, but product was only 1 because addition reaction. 2 of them came or 3 of them came, got added, 1 product. Yes. Oxidation reaction also is kind of same thing. You're using an oxidizing agent and that gets sort of added and sometimes further oxidized, and you have a combined, a product which has oxygen combined in it. Yes. Not exactly same. I'm not saying same. Sort of, kind of. Oxygen is kind of added. Yes or no? Yes. Not substituting anybody. Now, first time you're getting something which is totally different in the purview of alkynes. What is that? Substitution is going to happen here. Let's see how. Only one alkynes gives substitution reaction and show acidic characters. Please write this down as an important note point. You will not see that happening in alkenes. Among the unsaturated hydrocarbons, in alkenes also it's possible, but among the unsaturated hydrocarbons, especially alkynes, it's only one alkyne. That means terminal alkynes are the only ones where substitution is possible. If you have, let's say, butyne, it will not undergo substitution reaction. Are we clear with this? Yes, are we clear? You have to have a terminal alkyne. That's why only one alkynes give substitution reaction. And why does that happen? And how does it show acidic character? Basically, this carbon becomes so electron rich. This hydrogen becomes delta positive. It tends to leave, and that's why, because it tends to leave, acidic character is showed by terminal alkynes when they undergo substitution. Let's see how. Okay. So acetylene is a dibasic acid, correct? Whereas propyne is monobasic acid, acetylene can give 2 H pluses because both the sides we have H pluses. Yes or no? They are dibasic in nature. But when it comes to propylene or butylene, I'm talking about terminal, please. Terminal propylene or terminal butylene, please remember, in all those cases, there's only one hydrogen which can be given off. So they are all monobasic in nature. Yes. Only and only acetylene has hydrogens on both sides which can be given off. Nice. Beautiful. Everybody understood? Okay. So formation of sodium acetylides. So when they give away that 1 H plus by the action of some base, correct? In this case, a strong base is taken, which is a combination of sodium and amine, forming sodamide, correct? NaNH2. That NaNH2 here behaves as a base, and when it comes in close vicinity to, let's say, acetylene, Na plus goes and combines, basically substitutes one of the H plus, as you can see here. Is that clear? Substitution is happening? Yes or no? Very clear substitution. Yes, Na plus substituting H plus. So what do you have now? This fellow will be called as monosodium acetylide. Acetylene has turned into monosodium acetylide. Yes, like how do you call sodium chloride? IDE is the suffix. Chloride, sulfide. Yeah, exactly same way here. This acetylene has become, like chlorine becomes chloride. Similarly, acetylene becomes acetylide. Nothing new here. I hope you can make sense. Yes. Next, what is happening? Bring another mole of that, another H plus will be given off, because we already saw it is dibasic in nature. Nice and easy. Understood? Good. Yes. So you have disodium acetylide. Okay. Another beautiful thing. When you take this, correct, and expose it to some, let's say, some acid, some dry alkynides, generally are unstable in nature and also explosive also in nature, and they easily get converted to their original alkenes. Very soon they will give away their Na plus and all that, yeah, and turn into their alkynes. Why? As soon as you take any dilute acid also, I'm not talking about concentrated, even dilute acid, few drops also if comes there, you will find quickly it will explosively react with it, giving away Na plus, and again substituting Na plus with H plus, taking that from the dilute acid, coming back to its original form, forming acetylene, and sodium nitrate will be given off. Make sense? Yes. Where do we use these reactions? This is very important. This reaction is many times used, most importantly, for purification, separation, and identification of terminal alkynes. Please write down there. That's why it is important. Another note pointer, by the way. There's another note point, very important note point. Please write this down. Yeah. Where do we use these type of reactions? Exposing these, first of all, sodium, disodium alkylides to dilute acids whenever we have to purify, separate, or identify terminal alkynes. Good. Let's move on quickly to the next part. Now, sometimes if you expose these ethyne, or basically any type of alkynes, to terminal alkynes, to copper or silver acetylides, what will happen? To copper and silver nitrates or something like that, or copper chloride or silver nitrate. I mean, what are they called? Do you know? If you take ammoniacal solution of copper chloride and silver nitrate, they together are called as a very powerful, decently powerful oxidizing agent with the name Tollens reagent. I hope you've heard about it. Yes. And if you pass a terminal alkyne, which is gaseous in nature, most of the time, yes, unless until it is too heavy, if you pass it through this reagent, bubble it through this oxidizing reagent, what will happen? Copper as well as ammonium, they will have a substitution happening among themselves. So one of the ammonium will take one of the chlorine, forming ammonium chloride. Correct? Correct. H plus from the alkyne will be taken, will be substituted by whom? Copper. So copper goes there, forming copper acetylide, ammonium chloride. Correct? And that H plus which was substituted combines with the hydroxide ion of the ammonium hydroxide, forms water. Nice. Is this clear? The beauty about this reaction is what you obtain is a red color precipitate. So it's a kind of test for unsaturation. Nice. This is also a kind of test for unsaturation. Yes, alkanes will not undergo this reaction. Good. Okay. Tollens reagent combining with any of the alkynes, producing copper acetylide. Now, sometimes in place of copper chloride, if you use silver nitrate, ammoniacal silver nitrate, rather than ammoniacal copper chloride, this time silver will go and substitute H plus, and you will have a white color precipitate. Sometimes bit silvery also, because silver is joining here, na? So the inner walls of the test tube will become silvery in color. It's a very beautiful experiment. I have actually kind of done it in labs and shown it to many students. You must you can do it. I mean, labs Tollens reagent is very easily available. So ammoniacal cuprous chloride, if you use it, That means when we say ammoniacal, what do you mean? Ammonium hydroxide along with cuprous chloride. Or when you say silver nitrate, ammoniacal silver nitrate, that is tolerance reagent. Are we getting my point? Are you getting my point, dear? Yes? Okay. So when you use tolerance reagent, then this test is also called as silver mirror test. Silver mirror test. Also another form of test for unsaturation. This time ammonium ion combines with the nitrate ion, forming ammonium nitrate, and H plus, which was substituted from the alkyne, combines with the hydroxide ion, forming water. Good? Yes? Why do we use these reactions? Again, a note point here, very important note point. This hydrogen, which is connected to a terminal alkyne, is called as acetylenic hydrogen. Acetylenic hydrogen. The test for this, or detecting this acetylenic hydrogen, basically detecting a terminal alkynes or differentiating a terminal alkyne from a non-terminal alkyne, we go for these reactions. Beautiful. Is this clear? If you have to identify between whether the triple bond is at the terminal carbon or somewhere in the middle, carry out this reaction. Nice. I mean, these reaction, not just this, even the above one plays a role there. Make sense? Yeah. But this one specifically, because why this one specifically? How do you carry out the above one is over? There's no color change, all that happening. This is quite evident. Either red color precipitate will form if you're going for ammoniacal cuprous chloride, or a silver mirror test will happen. Silver color precipitate will form. Yes or no? If you go for tolerance reagent. Nice and easy.